Today's topic is all about the layers of the Earth. It can be divided into two ways, mechanical and chemical. The mechanical layers of the Earth are differentiated by their strength. There are multiple layers under this category: lithosphere, atmosphere, upper mantle, lower mantle, D double prime, outer core, and inner core.
First is the lithosphere. The lithosphere includes both the crust and the brittle upper portion of the mantle. The lithosphere is both the coolest and the most rigid of Earth's layers. The most well-known feature associated with Earth's lithosphere is tectonic activity. Asthenosphere. The asthenosphere is the denser, weaker layer beneath the lithospheric mantle. The temperature and pressure of the asthenosphere are so high that the rocks soften and partly melt, becoming semi-molten. The upper mantle. The upper mantle of the Earth is a very thick layer of plastic molten rock inside the planet. This layer is responsible for the movement of the tectonic plates as it contains slowly moving lava currents that make the plates move, which is often associated in continental drift. Although considering the high temperature of this layer, its state of matter is almost solid, plastic in viscosity due to intense pressure. Lower mantle. The lower mantle is much less ductile than the upper mantle and transition zone. Although heat usually corresponds to softening rocks, intense pressure keeps the lower mantle solid. D double prime. Beneath the lower mantle is a shallow region called D or D double prime. In some areas, D is a nearly razor-thin boundary with the outer core. In other areas, D has thick accumulations of iron and silicates. In still other areas, geologists and seismologists have detected areas of huge melt. Outer core. The liquid metal of the outer core has very low viscosity, meaning it is easily deformed and malleable. It is the site of violent convection. The churning metal of the outer core creates and sustains Earth's magnetic field. Inner core. The temperature of the inner core is far above the melting point of iron. However, unlike the outer core, the inner core is not liquid or even molten. The inner core's intense pressure, the entire rest of the planet and its atmosphere, prevents the iron from melting.
The chemical layers, they include the crust, mantle, and the core. They are called the compositional or chemical layers because they correspond to their material or elemental compositions. The following are brief overviews of the compositional layers of the Earth.
Core. Earth's core is extremely hot, dense center of our planet. The bowl-shaped core lies beneath the cool brittle crust and the mostly solid mantle. The core is found about 2,900 kilometers or 1,802 miles below Earth's surface and has a radius of about 3,485 kilometers or 2,165 miles. Mantle. The mantle is mostly solid bulk of Earth's interior. It lies between Earth's superheated core and its thin outer layer, the crust. The mantle is about 2,900 kilometers or 1,802 miles thick and makes up 84% of Earth's total volume. Crust. The crust is the outermost layer of the planet, the cold and hardened part of the Earth that ranges in depth from approximately 5 to 70 kilometers, or approximately 3 to 44 miles. This layer makes up only 1% of the entire volume of the Earth, though it makes up the entire surface, the continents, and the ocean floor. That is all of the layers of the Earth.